Welcome to our tutorial on SQL relationships. Today, we'll dive into the world of data integrity with primary keys and foreign keys. First up, we'll introduce you to the concept of relationships in SQL databases. Next, we'll explore what a primary key is. Think of it as the unique identifier for each record in your table. Then, we'll define foreign keys, which establish links between tables by referencing these primary keys. We'll also cover different types of constraints to ensure data consistency and accuracy. Finally, we'll show you how to create tables with these relationships in place. By the end of this session, you'll have a solid understanding of how to build robust database structures. Welcome to our lesson on SQL relationships. Imagine you have two tables, one for customers and another for orders. Customers need a unique identifier, which we call the primary key. In this case, it might be a customer ID number. Now, when an order is placed by a specific customer, that's where foreign keys come in. They connect back to the customer table using their ID, forming a relationship. And let's not forget about constraints. They're like the traffic cops of your database. They make sure you don't accidentally put duplicate data or invalid values into your tables. Common types include not null, forcing something to always have a value. Unique, ensuring no duplicates. Check, setting specific rules for valid entries. And foreign key, keeping all these pieces nicely linked. So, keep those relationships strong and your database healthy with primary keys, foreign keys, and constraints. Hey there! Welcome back to our SQL series. Let's dive into understanding primary keys. Think of primary keys as the unique identifier for each record in your table. They must be both unique and not null, which means every row must have a distinct key. You can use one column or multiple columns together to form a composite key. Importantly, just one primary key is allowed per table. Common examples include ID, customer ID, or product code. These keys are super important because they help us uniquely identify and reference data in our database. So keep that in mind as we move on to foreign keys and constraints next time. Welcome to our SQL tutorial. Today we're diving into the world of tables and keys. Let's talk about creating a table with a primary key. This is crucial for ensuring each row in your dataset has a unique identifier. In this example, we create a customers table with 3 fields: customer ID, name, and email. Here's how it looks in code. Let's break this down. Is defined as an integer and marked as the primary key, ensuring it uniquely identifies each customer in our database. The field can hold up to 100 characters, while it can store longer strings, up to 150 characters. This setup not only keeps your data organized, but also helps prevent duplicate entries, making sure you have a clean and efficient database structure. Alright, let's dive into foreign keys. Imagine you have 2 tables, one for orders and another for customers. To link these tables, we use foreign keys. Think of a foreign key as a pointer from one table to the primary key in another table. For example, in your orders table, you might have an order ID column that links back to the customers table via their customer ID. A foreign key can be just one column or multiple columns depending on your needs. It doesn't have to be unique and can even contain null values. So, if a customer hasn't placed any orders yet, there's no need for an order ID in the orders table. Welcome to our tutorial on creating tables with foreign keys in SQL. On this slide, we see the code for creating an orders table. Let's break it down. First, notice the order ID as a primary key, which uniquely identifies each order, like your social security number. Then, there's a customer ID, referencing another table called customers. This is where foreign keys come in. They ensure data consistency by linking records across tables. Here, we're saying that every orders row must have a corresponding customer ID in the customers table. So if you were to try inserting an order without a valid customer ID, SQL would reject it. This constraint ensures our database remains accurate and reliable. Welcome to our exploration of different types of constraints in SQL. Let's dive into the details. First up is not null, which ensures that every entry in a column must have some value. No blanks allowed. Next, we have unique, guaranteeing that all entries in a specific column are unique, perfect for primary keys too. Then, check comes into play when you need to enforce a specific condition on the data, like making sure ages are positive numbers. Default helps set a fallback value if no other is provided, ideal for optional fields. Lastly, we'll touch briefly on primary key and foreign key, topics already covered in our previous session. These constraints are your tools to keep your database neat and tidy. Welcome to our tutorial on adding constraints to tables in SQL. Today, we'll focus on the employees table. You see, when creating this table, we need to ensure data integrity and consistency. Let's break down each constraint used here. First off is set as a primary key with the clause, ensuring it's unique for every record. Imagine each employee having their own unique ID like a social security number. Next, cannot be null. This means every entry must have a name, just like you need to fill out your full name on any form. Then, we add a check constraint on the column, making sure employees are over 18. No underage workers here. Lastly, defaults to 5,000 if no value is provided, similar to setting a default price for an item in a store when you don't specify one. These constraints help maintain clean and accurate data. Welcome to our tutorial on creating tables with relations. Let's break down the key components. Think of primary keys as unique IDs for each record in your table, like a person's ID number. Foreign keys are like friendship bracelets, linking these IDs from one table to another, keeping things connected. Constraints are the rules that ensure data is accurate and consistent, much like traffic lights guide safe road travel. Common constraints include making sure certain fields aren't empty, not null, ensuring values are unique, and setting limits on what can be entered, check. By carefully structuring your database with these elements, you maintain a well-organized system that's reliable for all its users. Welcome back to our Database Fundamentals series. Today, we're diving into the summary of SQL relationships. First up, primary keys. They act as unique identifiers for each record in a table, ensuring no duplicates. Next, foreign keys are your trusty tools to establish connections between tables by referencing these primary keys. Constraints come into play here too. They ensure that your data remains clean and consistent. By using all three of these features properly, you can build efficient and scalable databases. It's crucial to always define clear relationships for seamless data management. So, whether you're building a simple app or a complex database system, understanding SQL relationships will take your tech skills to the next level.